Today, I want to go over balancing chemical equations. So, remember the law of conservation of matter, and this says that because of the law of conservation of matter, each equation must be balanced. So, that means it must have the same number of atoms of each element on both sides of your equation. And the person responsible for this law is Antoine Lavoisier, and there's a drawing shown of him. So coefficients are used to balance the equation, and these are the numbers in red in this equation. And these are whole numbers in front of a formula. They distribute to the each element in your formula, and these specify the relative number of moles and molecules involved in the reaction. So here we have an example of an unbalanced and balanced equation. So the first equation, we can see we have two hydrogens, two chlorines on the reactant side, but one of each on the product side. And as you can see, the reactant side is heavier in terms of atoms than the product side. And here, when we add coefficients and a coefficient to your product side, we see that we now balance out the hydrogen and chlorine, and they both have the same mass or same number of atoms on each side. So that is our goal. So here we have a reaction between carbon and oxygen to form carbon dioxide. So we can see that this has the same number of atoms of each, so it is balanced. But let's go over if it weren't balanced. So let's look at a different reaction. So here we have carbon plus oxygen goes to carbon monoxide. So we cannot change the formulas of the reactants or the products. We can only change how many we have of each, in this case, atom or compound. So here we need another oxygen in the product side. So to do that, we're going to add another carbon monoxide. When we do that, this will change the number of carbon monoxide molecules. And now we see our oxygen is balanced, but our carbon is no longer balanced. So we're going to have to add another carbon atom to our reactants. So where does it come from? We just add another one. And now our equation is balanced. We have two carbon atoms, two oxygen, and two oxygen. And that is our balanced equation. So to increase the number of carbon atoms in the carbon monoxide molecules, we have added coefficients of 2 to the carbon and 2 to the carbon monoxide. So when you're balancing an equation, you can never change a subscript to balance the equation. If you change the formula that you write, you're describing a different reaction. So for example here, we can't just make the subscript for oxygen be a 2 instead of a 1, because that would mean instead of having water, we would have hydrogen peroxide, which is completely different. You could never put a coefficient in the middle of a formula. So you could put a 2 in front of sodium chloride, but we can't just put a 2 in the middle here. That would almost look like a subscript. So some suggestions to help you is to first balance the metals, then balance the nonmetals, balance the oxygen, then the hydrogen. And a shortcut is if you have polyatomic ions that appear on both sides of the equation, you could treat these as independent units to make it easier. So kind of treat them as an element. If you're stuck and you get into a situation where everything balances except for the oxygen and there's no other way to balance the oxygen with a whole number, double all the coefficients and try again. And this is possible because oxygen is a diatomic element. Also, when you have an element that has an odd number of atoms on one side of the equation and even on the other side, try multiplying the odd side by 2 to help you. So just some different tips. Okay, so let's look at some examples. So let's look at an example. Here we have the reaction for the formation of water. Some students find it useful to make a table to keep track of the different atoms in the reactant side and the product side. So let's construct a table. So here we have, on the reactant side, we have 2 hydrogens. On the product side, we have 2 hydrogens. But we can see on the reactant side, we have 2 oxygens, but on the product side, we just have 1. So while we're balancing, we can keep track of any changes to the number of atoms by making changes in this table. So since the oxygen is not balanced, we could first add a 2 in front of water to give us 2 oxygens on the product side. So let's do that. So we add a 2. And when we look at our table, we can see that this will change the number of oxygens on the product side. So instead of 1, we now have 2, but it also changes the number of hydrogens. So instead of 2, we now have 4. So since the hydrogens are no longer balanced, we're going to have to add more hydrogens to the reactant side in order to balance our hydrogen. So we're going to add a 2 in front of the hydrogens on the reactant side. And when we do that, we see with our table that now we have 4 hydrogens on the reactant side and on the product side. We also have 2 oxygens on the reactant side and 2 oxygens on the product side. So now our equation is balanced. So by using a table, this can just help you to kind of think through the balancing. Okay, so let me do some other examples just to help you guys, just some techniques to help you balance. So in this situation here, we have an odd number of oxygens on one side and an even number on the other. So I said usually use end with oxygen, but in this case, we're actually going to start with oxygen. Since aluminum is by itself, that'll be pretty easy to balance at the end. So we could think about what 2 and 3 both go into. So they both go into 6. So I can add a 2 here on the product side to make that 6, and a 3 here on the reactant side to make that 6. I also see I have 4 aluminum, so I can add a 4 here to balance out the aluminum. Now, some students, to help them keep track of their number of atoms, instead of making a little table, they kind of keep track of it underneath. So they would say, okay, I have aluminum is 4 now, oxygen is 6, and then here aluminum is 4, and oxygen is 6. So we can see that's quickly balanced. In this problem, we have another situation where we have a 2 here, we have 10 here. So we could think about 2 goes into 10 5 times. And then we would add a 4 here to make that balanced. Now, when you have something like this is a combustion reaction. Now, to make this a little easier to balance, there's a method called the Cho method, which helps with balancing. And this simply means you would start with a carbon first, hydrogen second, and save the oxygen to last. So we can see here in this problem, carbon is already balanced. So we're going to start with the hydrogen. We have 4 hydrogens on the reactant side. To get 4 on the product side, we're going to add a 2 here. Now we have 4. Now we need to look at the oxygens. We have 2 plus 2 oxygens, or 4 oxygens on the product side. We can add a 2 here to give us 4 oxygens on the reactant side. We can see now this reaction is balanced. And this technique works when we have equations like this with only carbon, hydrogen, and oxygen in them. Let's look at another one. This is another one I want to go over here. What I want you to look at is we have 2 here for hydrogen, and we have 2 plus 1 here for hydrogen on this side. To balance this, another technique I can use is to think about larger numbers that these could go into. So let's start with a 4. Make the number of hydrogens on the reactant side of 4 by adding a 2 here. So 2 plus what would give us 4? We could put a 2 here to make that 2 plus 2 gives us 4. And we also notice we have 2 oxygens, and 2 sodiums. So we're going to add a 2 here for the sodium. Here we have a situation with a polyatomic. We can treat these polyatomics as a group since they stay together. We have one of those nitrate groups on the reactant side. We have 2 of them on our product side. So to balance out the nitrate, and we would start with that polyatomic. We're going to start with that nitrate. To balance that, we could add a 2 here. And when we do that, now we have 2 silvers. So we're going to add a 2 here. And now it's balanced. Okay, guys, so I want you to pause this screencast, try these 5 equations here, and then we're going to go over them. Okay, so let's go over these reactions here. So for the first one, we could start with the oxygen because the mercury is already balanced. To do the oxygen, we would need 2 more on the reactant side, and then we would need 2 mercuries on the product side to balance this. For the second one, I would leave potassium to last because that'll be pretty easy to balance. And we see here we have 2 nitrogens. I would add 2 here to balance the nitrogen. And then I would add a 6 to balance that potassium. With the next one, we see here that oxygen is all over the place. I would leave that to last. And I can either start with the hydrogen or with the potassium. And since potassium is a metal, I'm going to start with the potassium. When I do that, I can see now I have 2 oxygens on the product side, and I have 1 plus 2 oxygens here. I have 2 hydrogens on the product side, and I have 2 hydrogens there, and potassium also is balanced, so I'm good. With the next one, I would leave antimony to last, but you can think about, we have 2 here, we have 6 here, so what times 2 gives us 6? That would be 3. And then I need 4 antimonies. With the last one, we have a 3 here and a 2 here. So I'd actually think about what 3 and 2 both go into. They both go into 6. So I would make that a 3. I would make that a 2. And then I would put a 2 here to balance that. I want to go over one more reaction just to show you a particularly challenging situation you might run into with your homework. And this will be a problem with a combustion reaction where we use the Cho method, but this one's a little bit more challenging than the one I showed you earlier. So we have a hydrocarbon containing just carbon, hydrogen plus oxygen going to carbon dioxide and water. So like I told you before, we're going to do the carbon first and the hydrogen second, oxygen last using the Cho method. And you notice here I put a line in front of each of my reactants and products, and this is just a reminder that I only change things on those lines. I'm only adding coefficients and not changing subscripts. So we start with the carbon first. To balance the carbon, we put a 2 here. We notice the hydrogen is already balanced. So now let's look at the oxygen. So we have 2 times 2, which is 4, plus 1 is 5 oxygens. Now I want you to think of any number that will go into 5. It would be 2 times that would give us 5. And does not have to be a whole number. So hopefully you thought of 2.5 So we're going to put a 2.5 here. But you guys have never seen a coefficient of that has a decimal. So this is when we have to double everything to make everything balance and to give us whole numbers. So this is going to become a 2 here. This will become a 5. This will become a 4. And this will become a 2. And if you double check that, you're going to see that this balances. So balancing does take some practice. It's kind of like puzzle solving. So the more you persist through the problems, the better you're going to get at it. So I want you to try the homework, and then we'll go over any ones you're having trouble with tomorrow or next class. But just make sure that you're just really trying hard. But if you're getting very, very stuck, you can skip one and then we can go over it.